find the prime factorization of the numbers, and then find the LCM. So as I covered it before, there's different ways to do prime factorization. You can use divide by primes, which is fine. I like to use the factor tree. You can also use the list of multiples, one list of multiples. But this kind of a problem begs the factor tree, I think. The one list of multiples works nicely when the numbers, when it's easy to spot visually that the numbers will match at a common multiple pretty quickly. Here, I don't see that happening, right? These are oddball numbers. So we're going to use the factor tree to figure this out. So step number one is we have to break both numbers down into the prime factorization. So I'm going to put the 75 here. I'm going to create a factor tree here, and then I'm going to put a divider here on purpose, and I'll show you why later, and I'm going to put 189 here. And I'm going to break this down using the factor tree. So let's start over here. Now, we got to come up with what times what is 75. Now, again, here's where the divisibility rules really come in handy. This ends in 5, so I know 5 divides into it for sure. I know that 5, which is prime, so I'm circling it. 5 times something is 75. I know that for a fact, since this ends in 5 using my divisibility rules. Now, 5 times what is 75? I don't know, but I'm about to find out. I'm going to divide 5 into 75 to see what this is. 5 divides into 7 once, so quick and dirty here. I'm not going to spend much time talking about this since you already mastered this, right? You did. Correct. So 5 times 15 is 75. Now, is 15 a prime number or a composite number? And you said composite. Correct. Because 3 times 5 is 15. Prime, prime. We're going to do the same thing here. What times what is 189? I have no idea, but I'm going to use the divisibility rules to help me. 1 plus 8 is 9. 9 plus 9 is 18. 3 goes into 18. And also 9 goes into 18. Because remember, for the rules of divisibility, the 3 and the 9 have the same rule. Add the digits. And if the sum of the digits is divisible by 3 or 9, then the original number is divisible by 3 or 9. Instead of choosing 3, though, I'm going to choose 9. Why? Because I'm going to get a bigger reduction, right? I'm going to bring this down even more because I'm going to divide 9 into 189. So I'm going to do that right now. 9 into 189. Now, sometimes this happens, and it's nice when it happens. 9 goes into 18 2 times, nothing left over, right? 9 goes into 9 once, nothing left over. Sweet. 9 times 21 is 189. Quick and dirty, long division, nothing fancy here. All right, 9 is composite. That can be broken down into 3 times 3. 21 is composite. 3 times 7. Okay, all that work. Now we can actually start getting into the concept of the least common multiple here. All right, now do you recall that for the least common multiple, we're looking for the biggest, right? We're looking for the biggest. So, in fact, let's do this. I'll just maybe do this one time. So we have 3 to the first, right? Only 1 3, and then 5 to the second power. You don't have to do this, but I want to just show it to you here anyhow. We have 3 3s and 1 7, right? 1 7 there, 1 7. All right, so let's find the LCM. So we're looking for, again, big, biggest. Big is the keyword. Large, big. So let's look at the threes first. Let's compare the base of 3. We have 1 3 here, 3 3s here. There are more 3s here. Bring the 3 3s down. Okay? Now, let's continue. Let's look at the next number in sequence, 5. There are 2 5s here, right? 2 5s here. And if you want, you don't have to do this, but just to show you, there are no 5s here, which this is really 1, right? 1, and 1 times this is this. So it doesn't change anything. But just to show you that when you compare, there really are more 5s here because there's 2 of them here. There are none of them here. So, so we bring 5 to the second power down. And then we're done on this side. Now we switch to this side. We already looked at 3s. We already looked at 5s, but we have not looked at 7s yet. There's 1 7 here. And if you want, again, you don't have to do this, but this kind of shows you that, yeah, there are no 7s here because 7 to the 0 is 1, and 1 times this is this. This doesn't change anything. It's just for visual effect. There are more 7s here than there are here. See, there's 1 7 here. There are 0 7s here. So this, since we're looking at big, bigger, more, right? More, bigger for LCM, this comes down. This comes down. So all we got to do now is just simplify this thing by multiplying it out. So let's do it down here. Now, remember, this is the same as 3 times 3 times 3, right? It's not 3 times 3. It's 3 times 3 times 3. And this is 27. 27. 3 times 3 is 9. 9 times 3 is 27. This is 25, correct? Because 5 times 5 is 25. Okay? And then this is, of course, just 7. So we got to multiply all these out. We got to multiply those guys out. Okay, it's not going to be fun, but we have to do it. So 27 times 25. Quick and dirty, nothing fancy. $675 and then times 7, right? Times 7. 675 times 7. Because all these are in multiplication. We're multiplying these. Okay? So, 675 times 7. 49. Plus 3 is 52. 42 plus 5 is 47. Wow, that's big. Okay, so if I did my math correctly here, and we'll find out in a minute, the lowest number that exists in the universe that both 75 and 189 divide into is 4,725. Let's see if it works. Nope. All right, so I made a boo-boo somewhere. Okay, let's see if we can spot it. I'm not going to cut the tape here. I'm going to let it roll. I'm going to sweat under the lights. I'm going to sweat under the lights. until it's unbearable, then I'll cut the tape. So I made a boo-boo somewhere. Okay, help me out. 27 times 25. Oh, all right. Okay. All right. I'm way ahead of myself. So I'm not reading the instructions, George. The prime factorization of 75 is what they're looking for. So, all right. So, and they don't specify using powers. So it's going to be 3.5.5, right? It doesn't say using powers. So 3.5.5. See that? I kept my cool. I didn't push the emergency button. I was close. All right. So that's what I expect of you too. Just relax. If something's wrong, see if you can figure it out. All right. So for 189, the prime factorization is 3.3.3.3.7. And now we'll see if I'm right. I'm still not out of the woods yet, so let's see. Pressure's on. Nice. Nice. All right, so let's keep rolling. I'm going to erase this. Find the LCM of this set of numbers. Do so mentally if possible. So yeah, there's a point to be made here because I think it's kind of obvious, right, of what the LCM is. As long as you remember big, LCM big, and always think, could it be the bigger of the two? It is, because 4 goes into 8 and 8 goes into 8, right? Both the 4 and the 8 go into 8. So in this case, yeah, 8 is the LCM, since both the 4 and the 8 divide into that other 8, the LCM 8. Now, sometimes what happens is that if there's nothing, okay, actually, let's just do it here. So we have 2, and we have 7. Let's use the factor tree. Well, 2 is prime, so just bring it down, circle it. 7 is prime. Oh, okay. Bring it down, circle it. Oh, okay. So LCM equals. Now, we're looking for the most, the bigger, the greatest, right? In fact, let me see if it's in here. I want to show you. I want to show you this sentence somewhere in here, I believe. Maybe not. Okay. All right. But anyhow, they talk about the having the greatest amount, the greatest factors, the most amount of factors from each number to bring that down. I'll see if I can find it in a different help. Anyhow, back to this. So there's 1, 2 here. There are no 2's here. There are more 2's here, so the 2 comes down. We move on to the next number that's circled, which is on the other side of this division. By the way, the reason for this vertical line is like a wall here. I don't want my prime numbers getting mixed up between. I don't want them crossing sides because they're different numbers. That's why I put a divider here. So I want you to do the same thing. Put a divider so you don't accidentally, especially when you have big numbers. When you have big numbers, you're going to have all kinds of branches coming down the tree. And if you accidentally bring something close to this side, you might miscount it. So do this. On this side of the divider, we have a 7. And on this side, we have no 7s. So there are more 7s here. The 7 comes down. Multiply this out. 2 times 7 is 14. Now, if you can visually spot and see that there are no common factors between the 2 and 7, then you can actually multiply them out. That's what, in essence, we did here. See, there was nothing common here. We brought them down and we multiplied them. So if you can spot that, you can save a little time and avoid the factor tree if you can. 2 and 7 are both prime, and there's nothing common between both. Multiply them out. And 14 should be our answer. Because 2 goes into 14, and 7 goes into 14. Find the LCM. It says do so mentally. So what do you think the LCM is here? You said 9. Correct. 9. 3 goes into 9, and 9 goes into 9. That's why. So yes, bigger of the two. Doesn't always happen, but sometimes it does. And in this case, it does. So it's the bigger of the two. As long as the smaller number divides into the big number evenly with no remainder. Find the least common multiple of the set of numbers. All right, so we have 7 and 10. 7, 10. 7 is prime, bring it down, circle it. 10 is the same as 2 times 5. Circle, circle. LCM. 1 7 here, no 7s here. The side with the most comes down. There are more 7s here. The side with the most comes down. There's 1 2 here, no 2s here. There are more 2s on this side. This 2 comes down. Then we look at, so basically I'm comparing all the circled numbers between this divider. The circle numbers on this side versus the circle numbers on that side. There's 1 5 here, no 5s here. There are more 5s here. So you bring that down. Multiply this out. Now, 2 times 5 is 10. 10 times 7 is 70. We could have said 7 times 2 is 14, and 14 times 5, much harder. See how the rule of the associative property of multiplication, right? Yeah, multiply that first. That's easier because 2 times 5 is 10. 10 times 7 is 70. Nice. And again, we can kind of see here, right? There's no common numbers between. We got a prime 7. We got a 10, which is composite, but its factors is 2 and 5. There's nothing common between both. We could have just simply multiplied 7 times 10 and get 70. All right, what does it say? Use multiples of the larger number to find the least common multiple. So we've been using the factor tree right now for all these problems. And there's another technique called one list of multiples. Okay, one list of multiples. There's a separate technique called list of multiples where you take multiples of both numbers. To me, that's too cumbersome. I would rather do less work. So I want to do the one list of multiples. And the way that works is that you look and see 6 and 21. Does the small number divide evenly into the bigger number? And in this case, no, right? Not evenly. 6 does not divide into 21. So then you take the next multiple of the bigger number. So this 21 here is the same as 1 times 21, correct? So by the next multiple, what they mean is, okay, well, how about 2 times 21? That's what the multiple means. You know, 1 times 21, 2 times 21, 3 times 21, 4 times 21, and so on. That's what a multiple is. So what is 2 times 21? That's 42. And then you ask yourself again, does the smaller number divide into 42? We already know it does not divide into 21. Does the 6 divide into 42? The answer is yes. Yes. So we already know 21 for sure divides into 42 just from here. Look at that, because we multiplied it, right? There's your 21. 2 21s going to 42. But we must also check the smaller number. Does the smaller number divide into the result? Okay? And yeah, it does. 6 goes into 42 7 times. That means 42 is the least common multiple. Okay, this is the smallest number possible that 6 and 21 divide into. And we just used the one list of multiples technique here. We could have used the factor tree. It's good to know both. Here's what I recommend. Especially if the numbers are not too big. If the numbers are huge like they were that first problem that we did, use the factor tree right off the bat. If the numbers are somewhat small, try the one list of multiples for the first few multiples. And if you don't get a match, maybe switch to the factor tree. Because as you can see, this could be pretty quick, right? This could be pretty quick. So the downside to this is that if the numbers are odd, strange, let's say you got list of multiples for 27 and 62, yikes, that's kind of ugly, right? Use the factor tree for something like that. This is not too bad. You can almost kind of see where this is heading. See how knowing your multiplication tables really nails it? Twice that, 6 goes into it. Nice. All right, so let's try 42 and see what happens. Okay, so they want the same technique, which is good. Let's try the same technique. So we have 9 and 21. Well, 21 is the same as 1 times 21. Does 9 go into 21? No. Take the next multiple of the bigger number. 2 times 21, which is 42. Does 9, the smaller of the two numbers, does 9 go into 42 evenly? No. Take the next multiple of the bigger number, 3 times 21, which is 63. Does 9 divide into 63 evenly with no remainder? Yes, you said, because 9 times 7 is 63. Nice. Find the LCM of this set of numbers. Do so mentally if possible. So here, really, this is the same as this. To do it mentally, I mean, you wouldn't be able to do this mentally with the factor tree. I know I couldn't. So what they're saying is use the one list of multiples. That's what they're saying mentally. Well, let's try it mentally. See what happens. Can 3 go into 20 evenly? Nope. Take the next multiple of 20. 2 times 20, which is 40. Can 3 go into 40 evenly? Nah, right? Nah, nope. 3 times 13 is 39. Nah. Take the next multiple of the bigger number. 3 times 20 is 60. Does 3 go into 60? Yeah. 3 goes into 60 20 times, right? So 3 goes into 60. Now, you don't have to do it mentally, like they say, but sometimes you can do these mentally. Now, this is a kind of a big number. It's hard to do mentally, but you know, if you can, go for it. All right, so now we're coming on this concept called the LCD. LCD. What is the LCD that we hear about in fractions? Well, you know what? It's the same as the LCM. The LCM and the LCD are the exact same thing. The only reason they call it LCD because the D represents denominator. Okay, so it's still the lowest common multiple of the denominator. LCD, LCM, same thing. So now they want us to find the LCD for the following pairs of fractions. So for this example, we don't have to do anything really with the numerators, right? They don't mention anything to do with numerators. We only care about the denominators. So we have 6 and 5. Let's use the factor tree real quick. 6 and 5. 2 times 3 is 6. 5 is prime. Bring it down, circle it. LCM or LCD, same thing. Since we're talking about D here, put D here. It doesn't matter. Same number. 1, 2 here, no 2's here. There are more 2's here, so bring the 2 down. 1, 3 here, no 3's here. There are more 3's here. Bring the 3 down. 1, 5 here, no 5's here. There are more 5's here. Bring the 5 down. 2 times 3 is 6. 6 times 5 is 30. So 30 is our LCD. Now, one thing before I get to the last problem here, actually let's try this last problem because this might do what I was going to show you. Let's try the last problem. All right, so let's be careful here about what we're doing. So always read the blue stuff down here. Remember, oh, here they want equivalent fractions. Oh, okay, gotcha. We're still finding the LCD, but now we got to do something to the numerators. We got to keep the ratio the same by multiplying with something, and I'll get to that momentarily. So keep that in mind. And also, we're separating our answers with commas. Fraction, whatever it is, we're going to write it in here, comma, and then the other fraction. First step is to find the LCD between 15 and 12. Use the factor tree. One list of multiples will actually work okay, but these are big numbers, so go with the factor tree. 15 is 3 times 5. 12 is 3 times 4. 4 is 2 times 2. Good. This has what I was going to show you. This has that concept that I wanted to show you, so I don't have to bother showing it to you because it's right here. So let's look at it. All right. Now, same technique. LCM or LCD, right? Let's play nice. They want denominator. Let's start with the leftmost number here, 3. Now, there's 1 3 here, and there's 1 3 here. And this is what I want to talk about. We have a tie. We have a tie. There's 1 3 here and 1 3 here. Do we bring them both down? No, we don't bring them both down. We either bring this 3 down or that 3 down. It doesn't matter which one because it's still the most, right? It's a tie, but you can think of it as the most. So if there's ever a tie in the number of prime numbers of that number that's between both sides, either bring this side down or that side down. If there were 2 3's here and 2 3's here, either bring the 2 3s from here down or the 2 3s from here down, never from both sides. Because it's not going to be the lowest common multiple, it's going to be bigger, a bigger multiple. Not the lowest, but a bigger multiple. Not the end of the world, but you don't want to do that because you're going to get big fractions when you get to that. All right, so if it's a tie, one or the other comes down. Continue. 1 5 here, no 5s here. There are more 5s here, so the 5 comes down. We already looked at the 3. The 3's done. We looked at it. Now there's 2 2s here. There are no 2s here. Since there are more 2s here, the 2 2s come down. And we're going to multiply this out. Now, pretend there was a 2 here also. Pretend for a second. Let's say you had 1 2 here and 2 2s here. If you had that, still only these 2 would come down because there are more 2s. 2 2s are more than 1 2. Never from both sides, right? So don't bring all 3 down if there was a 2 here, and there's not. Just keep that in mind. You're going to see a lot of that in Math 50. All right, so let's see, where are we? So let's multiply this out. So this is 3 times 5 is 15. 15 times 4 is 60. 60. 60 is the lowest common denominator. So, but they don't want just that, right? They don't want that. They want equivalent fractions. Now, obviously, help will explain that, and I will explain that, but they don't want the LCD now. And really what they want here is the next step. The next step, which is to add and subtract fractions with different denominators. That is the gold standard. If you can do that, then you'll be good with fractions. All right, with different denominators. And that's what this is, different denominators. All right, so step 1 is done. We have our LCD of 60. Now what? It says use equivalent fractions. What does that mean? So let's take the 8/15 here. 8/15. Here's what that means. Now, remember, this is the lowest common denominator between 15 and 12, right? The 60 is the lowest number that 15 divides into and 12 divides into. So 60, right? 60 is the lowest common denominator. So here's what we got to do. We got to make the denominators become the same, because remember the last video, right? If we want to add or subtract fractions, and this is where this is going, we got to have the same denominators. So we got to use our LCD to help us here. In fact, this will be the denominator after we finish doing something. So what do we have to do first? Here's what we got to do. Put a multiplication dot in front of the 15. And then ask yourself, this is the denominator, right? Ask yourself, what number times 15 is 60? We want to know what number times 15 is 60. And you can use this to help you out. Because look, here's your 15 here, right? So what number times this? Well, 4. 4, see that? 4 times 15 is 60. Because we want to make the denominator become 60. Here and here. And we'll get to here in a minute. Now, can we leave this just like this? No, we cannot leave it like that because the way it is now, we just messed up the ratio if we left it like this. What we do to the bottom of the fraction, we have to do to the top to keep the same ratio. Notice that 4 over 4 is 1. So we're multiplying by a fancy version of 1. We're bumping this fraction up to match the denominator of the LCD. We're multiplying it by something to match the denominators. It's like we're using a magnifying glass to zoom in, to make it bigger. We're blowing this up by a factor of 4 to get 60 down here. But whatever you do to the bottom, you got to do to the top, so that way the ratio stays the same. All right, so what do we got? 4 times 8 is 32. 4 times 15, without even thinking about it. Without even thinking about it, we know the answer is 60. We know the answer is 60. Comma, like they said, they want a comma. And we're going to do the same thing right here. We got to get this fraction. This has to be an equivalent fraction to this, which means we got to make this become 60 also. We got to do the same process. We got to ask ourselves, what number times 12 is 60? And again, you can look here, right? Well, you know what? 3 times 4 is 12. Yeah, 3 times 4 is 12. Oh, so 12 times 5 then. 12 times 5 is 60. And by the way, this is in the multiplication table, which you've memorized, right? Nice. Now, if we're multiplying the denominator by 5, we also got to multiply the numerator by 5 to keep the same ratio. Let's multiply it out, see what happens. So we got 35. Again, don't even try to multiply it. There's our answer. We already knew it. All right, so let's kind of rewind a little bit. Let's go back and see what we did. So we used the factor tree. We used the factor tree to break down the numbers. We found, into the prime factorization, we found the lowest common multiple or the lowest common denominator. Then we used that denominator to help us bump up this fraction and that fraction. We blew it up, we made it bigger. This one by a factor of 4 and this one by a factor of 5. By the way, this number here, the 5 and the 4, these will never be the same. They'll never be the same because the denominators are not the same. That's why. That's why these, up and down, they'll be the same. Sure, up and down they'll be the same. They have to be, right? So we don't mess up the ratio. But this, whatever this is, in this case 5, and whatever this is, they'll be different for sure. All right, let's put that in here and see what happens. So they want this with commas in between. So right arrow to bring your cursor back up, comma, 35/60. Okay, so there it is. So this is how you perform the process of least common multiple and also finding the LCD. So if you like my content, click on the like button, post your comments, and subscribe to my channel. Thank you for watching.